You know, when you stop and think about it, what's the one thing that really powers our modern world? It's not the microchip, it's not even the internet, it's the battery. It is the silent, unsung hero making almost everything we do possible.
Seriously, just think about it. The phone in your hand, the EV you see driving down the street, even the huge energy systems that keep our power grids from collapsing. We are without a doubt a battery-powered civilization.
But here's the thing. The lithium-ion technology that got us here, well, it's starting to show its age. Our demand for more power, for longer life, for faster charging is just skyrocketing, and we're starting to hit a fundamental wall.
And this bottleneck, it affects pretty much every piece of tech we use and love. So let's dive in. What are the big problems with the batteries we all depend on today?
Okay, we've all been there, right? If you've driven an electric car, you know that feeling. Your eyes are just glued to that battery percentage, doing mental math to see if you'll make it to the next charger. Or, hey, maybe it's just your phone hitting that dreaded 10% right when you desperately need directions. That feeling? That's range anxiety, and it's a direct result of our current battery tech.
The truth is, we're really pushing lithium-ion batteries to their absolute limit. We're talking about EV driving ranges that still make people nervous, charging times that feel like forever compared to a 5-minute stop for gas, and yeah, safety. The core of these batteries uses a flammable liquid electrolyte. It's just a fundamental part of the design, and it carries this built-in risk of fire. We're getting to the point where we just can't safely cram any more energy into them.
But what if we could change the battery from the inside out? This is where a new technology comes in, one that promises to solve all of these problems at once. Let's talk about the solid-state battery.
So what is a solid-state battery? The core idea is actually super elegant. Imagine you take that flammable, liquid-soaked sponge that's inside a normal battery, and you replace it with a super thin, totally solid, non-flammable material, something like a slice of ceramic. That one simple switch is what unlocks a whole new universe of performance and safety.
And here you can see that difference, plain and simple. On the left, you've got today's tech with its volatile liquid, and on the right, you have the future, a solid, stable, and way safer core. This isn't just a small upgrade, it's a total redesign of the architecture, and the improvements it leads to are just staggering.
Let's start with the big one, range anxiety. Well, say goodbye to it. Solid-state batteries just have a much higher energy density. That means you can pack way more power into the exact same space. We're talking about the real possibility of EVs that can go 500, maybe even 750 miles on one charge. That's like driving from LA to San Francisco and back again with juice to spare.
Okay, and what about charging? Because that solid electrolyte is so much more stable, it can handle way higher currents. This means charging could get ridiculously fast. I mean, imagine pulling into a station and getting from 10 to 80% charge in under 15 minutes. That's not an improvement. That's a total game changer for making EVs practical for everyone.
And these things are built to last. The prototypes we're seeing can already handle over 1,000 full charge cycles while keeping more than 95% of their original capacity. You know what that means for an EV? That could be over 300,000 miles of driving before the battery shows any real signs of aging. That just massively extends the life of the car itself. So more energy, faster charging, longer life, and hey, we got rid of the flammable liquid, so it has to be perfectly safe, right? Well, this is where the story gets a little more interesting. We have this amazing promise, right? A battery that is, on paper, better in every single way. It really seems like the holy grail of energy storage that we've all been waiting for. But you know how it goes. With any massive leap in technology, there's always a catch. And while the hype is very real, so are the challenges. Just take a look at this quote from a recent scientific review. The key takeaway here is that while you get rid of the risk of a flammable liquid fire, that doesn't mean these batteries are totally risk-free. In fact, scientists are finding out they come with their own very unique safety challenges. So the problem really comes down to physics. The points where all the solid parts meet, the interfaces, are incredibly complex. Under all the stress of charging and discharging, tiny cracks can form, and that can lead to short circuits and overheating. And here's the wild part, because they pack in so much more energy, a failure in a high-density solid-state battery could, in theory, release even more heat than a lithium-ion one. So they don't fail in the same way, but they can still fail, and fail big. And you know, beyond these hidden safety concerns, there are just enormous practical challenges to get these batteries out of the lab and into the things we use every day. At the end of the day, making these things is just really, really hard.
Right now, the manufacturing process has super high defect rates. The cost is, well, it's astronomical, sometimes up to 5 times more expensive than lithium-ion. And the supply chains for all the special materials you need, they basically don't exist at scale yet. Tackling each of these is a massive job.
So that brings us to a realistic timeline. We've had years of lab research, and right now we're in this pilot production phase. We might see the first solid-state batteries in some very high-end, limited-run EVs around 2027. But for this technology to be in your car or your phone, we're probably looking at 2030 or maybe even later. So, with all those challenges, you have to ask, is the hype even justified? And the answer is, oh, absolutely. Because if, and it's a big if, but if we can clear these hurdles, the impact will be completely transformative.
And you just have to look at the money to understand the scale here. The market is projected to literally explode from about $500 million today to over $100 billion by 2035. This isn't some niche product. This is a fundamental shift in energy, and there is a tidal wave of investment trying to make it happen.
And why does all this matter to you? Because it's going to reshape everything. It means EVs, where range anxiety is a distant memory. It means safer, better grid storage that makes wind and solar power available 24/7. It means phones and laptops that go for days, not hours. It really is a quantum leap forward for almost every industry on the planet.
So yeah, the future of energy is, without a doubt, solid. The technology promises to fix the biggest headaches holding back our electric future. But the road from today's amazing lab prototypes to tomorrow's global standard is going to be paved with some incredible scientific and engineering challenges. The real question isn't if we'll get there, it's how bumpy that road will be and what new surprises, both good and bad, we're going to find along the way.